Hello, thanks for attending day 4 of Build with Mapbox. This is our first session of the day. I'm Chris Wong, Head of Developer Relations here at Mapbox. This session is Building with the Geofencing API for Mobile. Before we get started, a few logistical notes. All of these build sessions will be recorded and are available to view after the event in the Zoom lobby. You can hit the recording and watch it. You can actually speed it up if you don't want to watch it at regular speed. And then eventually they'll be on YouTube. We will invite live questions for the guests. So to participate, submit them using the Zoom Q&A feature. If you put questions in the chat, it may be harder for us to keep track of them. So using the Q&A helps us keep track of things a little bit better. Captions are available, so you can choose a language and enable those using the caption button at the bottom of your screen. And you can discover all of the build sessions available throughout the week in our Zoom event lobby. So we got a full day today and another whole full day tomorrow, packed with great sessions. So be sure to take a look and tune in for what interests you. That's all I've got. I'm going to turn it over to Åsa Forsell, who is a senior product manager in our Maps SDK team. She's joined by Patrick Leonard, who is a senior software engineer on the Maps SDK team, and they're going to tell us all about geofencing, which was just released this year, a very exciting feature. So take it over. Over to you, Åsa.
Thank you, Chris. Yeah, hi everyone. Thank you so much for joining this session. The agenda for today is that I'll do a very brief geofencing API overview just to introduce what it does and the kind of core example use cases, kind of a preview of what's to come. And then Patrick is going to do a real-time developer demo to show you some code and tell you how you actually use the APIs. And then at the end, we are going to reserve at least 10 minutes of time for a Q&A so we can answer any questions that you might have. Yeah, let's get started. So the geofencing API was released earlier this year, and it's now available both on iOS and Android. And the API itself is rather simple. It has all of the key features that you would expect from geofencing. So it allows you to define geofences in GeoJSON and allows you to also add, retrieve, and remove these geofences at runtime. And of course, the core functionality of every geofencing product is the ability to monitor these geofences. So whenever the user enters a specific area, it can send an on-enter event. Whenever the user exits a certain geographic area, it can send an event that the user has exited. And it can also send a dwell event in case the user stays within a geofenced area for an extended period of time. And then, of course, you as the developer can use these events to trigger different actions within your application or also use it for various different campaigns. The geofencing API itself works both on foreground as well as for background monitoring. So you can monitor the geofences when the user is actively using the application, but also once the application is in the background and the user is moving around there. The kind of specific advantages of our geofencing solution is that we support a very high number of geofences. I would like to say unlimited amount. I assume there's going to be a theoretical gap somewhere, but we don't artificially limit the number of geofences you can monitor at the same time. And we also have offline support, so you can continue using the service even if the application is offline for extended periods of time, as long as the geofences have been loaded to the device before it went offline. And of course, it's also compatible with Mapbox datasets and all of the other Mapbox services, so it fits right in with the overall ecosystem that we have going on. Then you might ask, okay, what do I do with geofences? So I'm going to go through some example use cases. For most of these use cases, we have real customers already using the API, and then a lot more who are experimenting with it right now. So one very generic use case for especially the outdoor space is notifying users when they're entering various different protected areas to provide added guidance. So for example, for a hiking application, you might want to notify your users when they are entering specific sites with scientific interest to warn them that there are specific rules in place here, very similar to when they're entering areas with active forest fire warnings, or perhaps in a hunting application if they accidentally exit the allowed hunting zone or they move from one property owner's area to another. So you can do a lot of guidance for the end users of your application with geofencing. Another example that our customers are doing is gamifying the application experience that they're in. And this means that you can use geofences to define event areas and then trigger various different events and actions when the user enter these areas. For example, if you have an event going on in a specific national park or in a specific part of the city, you can send a notification to the customer informing them of this event when they actually enter that geographic area. So you can do really targeted notifications and also really targeted actions in your application to make sure that those reach only the people who are physically in the location that matters. And then this also goes further. So of course, you can trigger various different offers and coupons as well. If you, for example, have stores, this is quite common use case for retails, where if you enter areas with the store of a retailer, you can trigger various different targeted offers or coupons that are relevant to it. And then more concretely, geofencing can help you enforce compliance with various different rules and regulations. And a very common use case that we are seeing is in micromobility, especially in these e-scooter and e-bike rentals, where you have a lot of regional limitations on what you can do. For example, there might be areas in the city where you cannot drive the vehicle. You can geofence those out and then notify the user when they enter a restricted zone. And you can also use this event to stop the scooter from working in that specific region. Or you can monitor that the parking happens in the appropriate location in the city so that you cannot stop a ride if you're not inside of a parking square. Another option here is to set geofences for areas with restricted speed limits. And then you can use the geofencing events to control the speed of the vehicle or the maximum speed of the vehicle to make sure that if you have a part of the city at a certain time of the day where you cannot go above 10 kilometers an hour, then geofencing will be your guide or can help you monitor and enforce those rules and regulations. So in short, geofencing can be used pretty much for anything where you want to restrict a service to a certain geographic area, or you want to monitor people's activity within that geographic area, or you want to automate something based on a physical location. And yeah, I think now I've talked enough about the hypothetical of what geofencing is. So I'm going to hand it over to Patrick, our developer, who is going to walk you through exactly how you use the API and how to start bringing it into your application. So off to you, Patrick.
Great, thank you. And I'll just switch to my screen share now. Great. And then, cool. All right, so I'll be walking through our geofencing tutorial for iOS and for iOS, but the same tutorial is available on Android. So you can follow along on either platform. It's the same concepts. The implementation will just be a little bit different if you're on Android. All right, but yeah, so basically this is a little example app we put together simulating a user driving around Yellowstone National Park and entering and exiting various geofences that we defined. So you'll see here that there's the blue location dot, and that's just mimicked GPX data. So it's a user circling around the park. You have latitude and longitude data, and this will be pretty much the same experience as if a real user was using your application and was entering and exit these geofences. Cool. So the geofencing service is the main entry point to working with geofencing in your application. So you can use the geofencing service to manage geofences, to start and stop observing events, to add specific observers, to remove those observers, and then to configure the geofencing service itself. So as you can see here on iOS, it's implemented as a protocol. So if we go here, you can see it. And this will just give you the methods for doing all of those individual actions. So the main ones you'll probably be using are to add features, get features and remove features. And so these are like how you would add a new geofence. And so we'll walk through an example of using a GeoJSON file to build those individual features and add them to the service. And then the other ones you'll use most likely are the add observer and remove observer. And those are the tools you'll use to watch for a user entering, exiting, or dwelling in those geofences, and then you can respond as you'd like in your application. So you can send a notification or change the UI or really do whatever you would like after those observations have occurred. Right, so in our particular example, so we are going to have the start function that creates the geofencing service. It clears out any old features you may have used and adds a new observer. And then it does some light configuration. Nothing, we're just going to use the defaults for now, but there are additional configuration options you can trigger here. And then additionally, we're going to expose this add feature method here. So that's just going to take a feature from the GeoJSON and then, or actually from the feature collection created from the GeoJSON, and then add it to the geofencer for observation. So we'll trigger this particular start right after the map load. So here in our UI code, we're going to do on map loaded. And then once that event triggers, we'll just start the geofencing service right here. Real quickly, so we have this GeoJSON that I created that's kind of simulating your geofences. And so we have the coordinates of all of these polygons that you see here on the map, and then just one property, the name. So in this case, it's just the name of that region, but you can put any kind of arbitrary information here. So you could put, if say this was a store, you could put information about opening hours, or you could put what products are available. And then you'll see that information is exposed later, and we can get it as part of the event when someone enters the particular region. So I have about 10 different regions here, and they're just in order of the circle we have here. Cool. And so we've read them into a feature collection using this little helper function. So it just decodes the GeoJSON at runtime and puts it into a feature collection. And then once the map loads, we will read that feature collection for every single feature we have in that feature collection. We will we will set the dwell time to 1 minute and then add it to the geofencing service to monitor. So the dwell feature is it determines when a dwell event will be sent. So we will just use 1 minute for demonstration purposes, but you can set this to any other value you'd like if you want a dwell to be considered 1 hour in a particular geofence or 30 seconds, whatever your needs are. But we will set that, and you'll see it kind of trigger on the map, I think, for the larger polygon. So this one, you may see a dwell event, and this one, you may see a dwell event. Cool. And so now that we've added those features, they are set up and ready for events to be observed. And so that we're going to turn a little bit down here. So we have this geofencing observer class, and we're going to, and that exposes particular events that you can monitor for to take action based upon. So we have on entry, on dwell, on exit, and then also these kind of helper ones of on error and then on user consent changed. So starting with the entry, it's exactly what you'd expect. So when the user enters the particular geofence, that event will trigger. And that works for the same event as well. So for here on dwell will be the same. As we mentioned, we set 1 minute as the dwell time. So once a user lingers in a particular geofence for over a minute, that event will trigger. And then finally, we have on exit, which will trigger when the user exits that geofence. The error and then the on user consent changed are kind of more for you. So on user consent changed, of course, you may want to take, so we will stop tracking the user's entry and exit when they do change the consent, but you may want to take additional actions for your application. And so we expose this for you to trigger any of those other cleanup actions you may need to implement based on your implementation. Cool. So this is kind of the basics of the geofencing service. So you have the geofences that you add to the service, and then you have the observers. And then now we're going to go on like how you might use this in your application. And so I've created a small geofence event that you see is being set here. And so just to move up that class. So what that does is we have this enum that just looks at the type of events and then sets this kind of formatted strings that we'll use just in a second. It has the feature itself, and so we'll use that to get the properties and then also the timestamps. So every time a new geofence event is triggered, we create one of these geofence event struct or an instance of the struct. We declare its type, we put the full feature, and then we also set the geofence name. And so here we're looking for the name property from the GeoJSON. So just to jump quickly back to the GeoJSON, you can see the name property here. And as I mentioned before, you can put any kind of information you want in that GeoJSON and then retrieve it at the event time. And then so here we're just going to put the name and we're going to use it eventually to add the little tag here, but you can use whatever kind of information is important for your use case. And then finally, we're going to add the timestamp, and that'll just say what time the user entered, dwelled, or exited the particular geofence. Cool. Now with that information, we are going to create this little event view. And so this is what you're seeing here. So right now it says entered Yellowstone Lake at 8:19 a.m. And that we just build just from the event itself that we just constructed, and then also just a little VStack with the basic kind of information. This is totally Swift code, so you can flexible as you desire for your implementation. And then the other portion we have here is constructing the map view itself. And so if you're new to Mapbox or working in Swift UI with Mapbox, generally the entry point you're looking at is the map. And so you have the map. Here we declare this initial viewport. The center point is the center of Yellowstone National Park. We're zoomed into level 9, so quite low. And right now we have the bearing and the pitch at 0, so they're pretty concentrated there. Just looking down on the, just straight down, looking down. So we add this puck 2D, and so that's the blue dot you see kind of circling around. So you can customize that for your particular needs. There's also no need to show the puck or show users location in order to use geofencing. So you can observe this in the background if you desire, or just not have it as part of like a interactive user location experience. I just included it here just to give it a little bit more of a demonstration of what it looks like when the user is circling around. Additionally, we have the GeoJSON source, which is the Yellowstone locations. So that is going to be the data source of the locations that's building these polygons you see here. Again, you don't need to show these visually on your application, so they can be invisible or not represented at all. But here we've just included them for demonstration purposes. And then finally, we have this fill layer, which adds the visual representation of the data held in the GeoJSON source. And then we're setting the fill color based upon the particular event type. And so we use a Mapbox expression here to do that. So we're matching the geofence type to a particular color. And so you can see them kind of pop up on the map as they go. So when the last event was an entry, the polygon will turn green. When it's an exit, the polygon will turn red. When it's a dwell, it'll be blue. And then for all other situations, it will be gray. And for our purposes, we're just kind of representing one event on the map, but you can do whatever you'd like with this type of information. So you could color all of the polygons if someone has been there differently from if they are, if someone's been there differently from if they haven't entered there at all. Or you could, again, choose not to represent this visually at all. And the map will work kind of as you'd expect any Mapbox map to work. So it's fully interactive. You can zoom in and out. And if you want the user to get closer. And so this can integrate into really any other type of application you're working with. And there's no need for it to work visually as well. And then the last kind of item we have here is this fill opacity, which just sets a little bit of a see-through nature to the particular geofences to make sure that you can see the underlying feature. Cool. So that's kind of a high-level overview of the geofencing service. I think for Swift UI-oriented developers, you'll see that we're using just an observed object for the geofencing service, and so the UI will update as necessary for those updates. There are different architectures you can choose if you're working in UIKit, or of course if you're working on Android. But generally, you'll want to be observing that geofencing service in some way if you want the UI to update. Cool. All right. Great. And then finally, in our UI code, so we have this overlay that I mentioned before, and so that will be the events view. And so this example will just take in the last events and display it here, but you can do as you like to implement that. Let's see what else. So I think that covers most of our code tutorial. As I mentioned, the code is available for iOS and Android as well. And so if you are interested in trying it out, please do so on either platform. But are there any specific questions about the code before we switch to the full question and answer session?
I see another question came in, but I don't think it's specifically about the code. So I think we can probably move on to general Q&A. Is that all right?
Yeah, that works with me.
Great. Awesome. So anyway, I broke my own rule and I asked a question in the chat because I'm a host and can't use the Q&A feature. But I was actually surprised to see that you can use an expression and actually tap right into the geofencing data. I figured you would have to read that somewhere and then go update the style separately. So I'm impressed that that's something we thought of that that you can do. Is there any more we can say about how that actually works, or is it or the design of that?
The expression kind of here for the UI layer, or
that you can actually tap right into the geofencing state right from the expression.
Sure, yeah. So everything is exposed to you. So we trust you as developers to build cool things, and so we want to expose as much information there. Yeah, so here I've done just kind of a visual expression of the last event type. But you could also do an expression based upon information about the feature itself. So for example, you may have some features that are so maybe some of these regions are restricted, and so when a user enters them, you want to show them in like a flashing red or something a little bit more extreme. So you can filter the expression based upon the type of the feature itself or any other property in the feature itself, in addition to information about the events that was triggered by the geofence. And I should share that so these are polygons we're representing, but we also allow you to have both points, and those would have like a little radius that would trigger, or you would trigger when you enter the radius of the point. And then we also allow multi-polygons. So for example, if you consider like these two polygons to be the same type of feature, you can enter them as one multi-polygon and just trigger the event for that overall. So slightly different use case, but again, the idea is flexibility for the developer and kind of allowing you to have whatever information you need to create the experience you desire.
Awesome, thank you. And there's a question from a user or from a viewer. The geofencing API is now available on iOS and Android, and they're wondering if that also means it's available on Flutter using the Mapbox Flutter SDK. And they're adding, this is a general question for all Mapbox mobile features. So is this available yet in Flutter? And if not, what's the process for that?
Yeah, I can take this one. It's not available on Flutter today, but it will be available on Flutter. So right now, the geofencing API is still tagged as experimental. So we just recently released it on iOS and Android native. We're gathering feedback from developers, and then once we feel like the APIs are in a pretty stable place, we will expose it also on the Flutter SDK. And I think the general question that was asked is for all mobile APIs really is that, yes, our intention is to bring all new features and all new mobile APIs to Flutter as well. So that includes anything like, for example, icon animations that we are bringing out later on this year, and the appearances, those will be also available on Flutter. And in general, it is not a Flutter session, but I can talk about the roadmap a little bit since it's also my product, is that next year we're going to be looking more comprehensively into the feature parity between the native SDKs and Flutter to bring those on par.
Great, thanks. So there's one more question from a viewer. My understanding is that the geofencing SDK for iOS acts as an abstraction layer on top of Apple's native core location services. This would mean that for a terminated app, Mapbox relies on the same iOS mechanism that relaunches an app for native geofencing events. Can you confirm? Is this understanding correct?
Yeah, so we do have to live with the operating system restrictions when it comes to terminating or collecting information or reawakening terminated applications. In the current iteration that we have available, there are some restrictions when it comes to that, and we receive feedback from early adopters. So in version 11.17 that is coming out later this year, we will have a more comprehensive support for this to ensure that the application gets awakened when you want to monitor the geofences on the backend. So I would say yes and no, partially right now and fully supported by the end of this year.
Excellent. Okay, and there's one more question about the native geofencing, right? So Android and iOS both have platform native geofencing options. Can you say more about how our implementation differs from what you can do with these native offerings?
Yeah, so I think mobile developers are aware that both iOS and Android have certain native geofencing capabilities, but these are quite restricted. On iOS, I believe the limit is 10 or 20 actively monitored geofences at a time. On Android, it's 100. And then there are some limitations like the number or the geometries that you can monitor. They're typically point geometries with a radius set around that. Versus for us, we have no limit on the number of geofences, and we can also support polygons and multi-polygons. So you have more flexibility there. Yeah, I think those are the biggest differences. And then also one of the bigger differences is that our geofencing API is pretty much identical across platforms. So you can use the same set of geofences and the same logic both on iOS and Android. So you don't have to develop separate set of rules and logic and geofencing setup between platforms. So you can have a more unified user experience across platforms.
Awesome. And in the demo, I think we saw enter, exit, and dwell. Are there other events we can listen to, or is that the full list?
Yeah, that's the current full list. You can, of course, define, like Patrick showed during the demo, the dwell time of when it triggers. So that gives you quite a lot of granularity, whether you want that to trigger after 1 minute or 1 hour or 7 hours. So that does gives you some more flexibility, but those 3 are the core geofencing events.
What happens if a user changes their location permission consent level? Because all this is very dependent on getting the real-time location, right?
Yeah, so on both platforms, both on iOS and Android, we live by whatever permission the end user has given the application. So the application permission level defines what location we get as a service. So if the user terminates the permission mid-session, it means that our geofencing API will stop working because we no longer receive those location events. So you need to at least have coarse location enabled to use geofencing. But if you want more accurate results, then you need to have precise location enabled.
Awesome. And can you tell us a bit more about offline use? I get the impression that this is all of this is handled locally. So you don't need to make any calls back to Mapbox to get it to work. But is there any more we need to know about offline?
Yeah, so the whole geofencing API, like you mentioned, it works fully on the client side. So as long as you have the geofences loaded to the application, whether they're baked into the application binary or they are loaded when the application is connected to the internet, we can monitor geofences offline. You don't need to do anything to enable it. It works out of the box. And this is because for the geofence monitoring, we're not sending anything to our servers. We are not doing the monitoring on our side. Rather, everything stays within your application's confines. And part of the reason why we wanted to do that was, of course, the offline capability, but also just overall data privacy and security, because you don't have to send those data points to our servers to be processed. Rather, you can choose how you process it and what you do with the events at your own discretion.
Awesome. And on that note, so we're looking at a static set of geofences here, which was pulled in from GeoJSON, from static GeoJSON that is located in the repo or in the project. Is it reasonable and feasible to do this dynamically and just, after a user moves around, you can just go fetch another set of geofences and just add them to the service on the fly? Can that be done?
Yes, so you could have one giant set of geofences globally that you can download and use, or you can have geofences specific to a locale or use case and then dynamically load them from wherever you're hosting it. So you could host a geofence GeoJSON on our servers using, for example, our datasets APIs, or you can host them on your own backend server. And then you just define the logic in your application on when to fetch those geofences. On top of that, you can also dynamically create the geofences on a client. So one example of this could be, let's say you have a smart home application and you want to create automation that lights turn on when you arrive at the house or close to the house. You could have the user define a geofence around their own house on the client, and then that geofence would be stored locally on the application, and then the application could automatically turn on the lights when the user enters that house geofence, for example. So there's multiple different ways you can set these geofences, and of course you can dynamically unload the geofences if you no longer want to monitor for certain ones.
Great. Yes,
Yeah,
and
I
it's
think-
all just GeoJSON, right? So you can draw your own, you can have the user draw it, you can grab it from whatever other store you have. So sounds very flexible and useful. Sorry, I cut you off, Patrick. Go ahead.
No, I was going to say the same thing. So what we're looking for is just a turf feature, and you can build that however you want. So from GeoJSON, so like one use case you could do is to have large GeoJSON, say for like a state level, and then when a user enters that large GeoJSON, you could switch to lower level GeoJSON. So say counties or townships or whatever you desire. So it is a very flexible system. So we're just looking for that turf feature, and then you can add it, remove it, or get it as desired.
So you're saying we could use the entry of a geofence to trigger getting more geofences? Is that what you're saying?
Yes, it's yeah. So you could. I guess geofences all the way down.
Geofences
You can
all the way down. Love it.
Yes.
Okay, I think that'll wrap us up for questions. Any other parting thoughts that you want to put out to to people who are trying to use geofencing from you guys?
Yeah, I think the biggest thing is that since the API is still experimental, so now is the kind of perfect time to try it out and give us feedback on it. So we can make any necessary adjustments or maybe bring out features that are missing before we, take it to GA by the end of this year. A good example is like one of the questions was, what about waking up terminated applications on iOS? We got that exact same feedback that it's not working exactly like the developer assumed it should or told us or thought that it should. So we are right now working on finishing that feature so that it works as expected before we go GA. And another kind of feedback we got from a developer that it would be really nice to have a way to see what geofences are being actively monitored for debugging purposes. So that's also another thing that we are bringing in before we go to GA. So yeah, if you have any feedback on the APIs, let us know. We really want to incorporate all of those learnings before we fully launch this to the world. Of course, it's already production quality. You can use it in your application, but we haven't yet frozen the API.
Excellent. Patrick, any other final thoughts?
No, just if you are looking for a place to provide that feedback, so our repositories for github.com/mapbox/mapbox/mapbox maps iOS or Mapbox Maps Android are a good place to put that feedback. Or if you're working with an account manager or a support engineer, they can also get that feedback to us as well. But yeah, as Rich said, we would love to hear your thoughts and make sure that we're incorporating that into any future developments. I will most likely be the one implementing this on Flutter as well. So I'm particularly interested in any feedback someone has for the kind of the Flutter API could look like. So please do share. Would love to talk to you.
All right. So there you have it. That's our new geofencing API feature for both of our mobile SDKs and soon coming to Flutter. So thank you for joining this session today. Thank you, Åsa and Patrick, for the great demo and overview. And thanks for attending Build. We'll see you at the next session.
Thank
Take
you
care.
all.
Thanks all.